if I wanted to lift this engine, I would have to be able to apply a force equal to the 600-pound weight of this engine. Well, that's a lot of force, and no, I couldn't do it. But the point is, the engine weighs 600 pounds. In order to move it up, I would have to apply a 600-pound force up. Well, the good thing is this. If I could apply a 600-pound force straight up, I wouldn't have to move it a whole lot. In order to get the engine from the ground where it is now into the car, I'd only have to lift it about 3.5 feet. But it's simply not possible. I cannot lift 600 pounds. I cannot apply a 600-pound force straight up. So we have the device called the engine hoist. This is a pretty modern piece of equipment. It involves hydraulics. Before hydraulics, a block and tackle was used. Now, a block and tackle is simply a series of pulleys hooked together. Using a block and tackle, I can also lift this force, this 600-pound force. But here's the cool part. If I wanted to lift this engine, I could, in one sense, apply a 600-pound force straight up, but only move it a small distance. That would require a lot of effort, a lot of muscular effort to apply 600-pound force. That's a lot of energy that I would have to exert to get this thing off the ground. Okay, this idea right here will give us the amount of energy transferred from the force doing it to the object. And in this case, we're going to increase the kinetic energy of the cart moving. Well, here's the kicker. Each one of these symbols is incredibly important, and it's important that you understand what each of the symbols means. So let's identify what each symbol is. This component right here is the force, obviously. But what we are concerned about here is the magnitude of the force. We're concerned with how big is this force acting and through what displacement. The magnitude of displacement. So how big of a force is acting through how big of a displacement? Now here is the very most important part right here. This theta right here is what defines, it's what defines how big a component of force that's acting along the direction of displacement. And so this angle right here, this theta right here, is the relative angle between the direction of the force and the direction of displacement. This piece right here is, in my opinion, the key to all understanding when it comes to work. Now, work, once again, has three components to it. This expression explains in a shorthand form about the component of force acting along the direction of displacement. But as we go further and further into our understanding of work, what we're going to see is that we need to know what the overall smash of force is acting and through how much displacement this smash is acting. But only the component of the whole smash acting through this displacement. And that's where this angle of theta comes from. Now, here's a huge piece to this statement. And this too is very important here. Regardless of the orientation of the system, the object and the force, the amount of energy transferred depends only on the component of force acting in the direction of the displacement. So regardless of orientation, of the object, the amount of energy transferred depends only on the component of force acting along the direction of displacement. Huge, huge, huge statement. Regardless of the orientation of the object, the amount of energy transferred from the force to the object depends only on the component of force in the direction of the expected displacement. So these two pieces put together really lay out the understanding of how you physically apply this expression of how much energy is delivered by a force.